Hello everyone, it's Angela, and today I'm going to be helping out Dr. Lee on his video on atomic orbitals and the periodic table. And at the end of the video, our goal is to be able to start writing electron configurations. But first, the periodic table. Now, this is just a general periodic table, and one thing to note is that when scientists first discovered the elements, they gave them names. So we have like hydrogen, sodium, magnesium, but even more than that, they gave them categories. So let me go through them real quick. We have our alkali metals, our alkaline earths, our chalcogens, our halogens, and our noble gases. And note the noble gases because they're really going to come into play later. So we have all our categories, and with increasing understanding of atomic structure and atoms in general, we can reorganize the periodic table into atomic orbitals. And so let me show you what that would look like real quick. And so this is the periodic table we recreated with atomic orbitals. We have our S, P, D, and F block. And note here that each of the orbitals can have a maximum of a certain amount of electrons. That's going to be really important with electron configurations. So we have the S block that can have a maximum of 2. We have the P block that can have a maximum of 6. The D block that can have a maximum of 10, and the F block that can have a maximum of 14 electrons. And so these are the blocks we have, but we can even break this periodic table down even more to show the different levels of the orbitals. So let me show you that right here. We have from the left to the right, we have 1s, 2s, 3s, 4s, 2p, 3p, 3d, 4d. And so as you can see, as you go down, the levels will increase. And so we're going to use this in order to begin to write electron configurations. So let's just start with an easy one. We're gonna go through 3 right now and end with a more difficult one for this video. Right, let's start with hydrogen. And one thing that we want to know is hydrogen's atomic number. And hydrogen's atomic number is 1. That means that hydrogen has 1 electron. And it is in the 1s orbital, as we can see. Let me go here. Go back. 1s orbital. And so that means we write its electron configuration as 1s1. Now let's get to helium. Helium has an atomic number of 2. And so that means it has 2 electrons and falls in the 1s orbital. So we write its electron configuration as 1s2. And now lithium. Lithium has an atomic number of 3, but we don't write it as 1s3. As you can see, it falls in the 2s orbital. And as I said earlier, the s orbital can only hold a maximum of 2 electrons, and these are 2 electrons. And so now we're not at 1s, we're at 2s. And so lithium's electron configuration can be written as 1s2, 2s1. All right, and these are the electron configurations. Simple as that. And so one thing that we want to note here is that when we're looking at the periodic table, we read it from left to right until we can't go anymore, and then we go down a row. And so let's use the atomic number of electrons to further write more electron configurations. We're going to focus on one, and I'll be working on my iPad for this one. All right, so we have a general periodic table, and today we're going to be working with sulfur. So let's look right here. Now, sulfur, if you work through a periodic table, has an atomic number of 16. This means that it has 16 electrons. So our goal is to go from left to right until we hit sulfur and can stop. Noting that an s orbital can have a maximum of 2 electrons, and a p orbital can have a maximum of 6 electrons. So let's go from left to right. We have 1s2. Now we must go down to 2s2. And now we've hit our 2p, but our sulfur is in 3p, so we got to cover this entire thing. It has a maximum of 6 electrons, so we write 2p6. Now we can't go to the right anymore, and we're at 3s, but we're not at sulfur yet, so we have to take all this into account. So I'll write this as 3s2, and then we are in our 3p orbital. Sulfur is the 4th element in, so we write it as 3p4. And it's as simple as that. This is the electron configuration. And now one thing I want to introduce is something called the noble gas configuration. This is a shortcut electron configuration, and this is where the noble gases are going to come into play. So we have our row of noble gases, and what we want to do is choose a noble gas that precedes our element that we need to classify, and we put it in brackets, and that assumes that we've covered the entire electron configuration before it. So say our noble gas that we want to choose is argon. We put argon in brackets, and that means that all these elements prior, they're all covered in the electron configuration. So let's do this for sulfur. Now, what element precedes sulfur? That would be neon. So let's start there. So I'll put neon literally in brackets. And now we're going to be starting here because all of this has been covered just by this. So we can now start at 3s2. Now we're at the 3p. Sulfur is the 4th element. So designate that as 3p4. And that is it for the noble gas configuration, just a little shorthand way of writing. And that's overall our video for today. I hope you found this helpful. Thank you so much for watching.